This video covers the concept of negation, which is in sections 1.1.3 through 1.1.5 in the book. Negation is used to change the answer, essentially, of a proposition to its opposite. In text, we would usually write the word not somewhere in line with the text statement. If I have a proposition that just says I'm eating chicken, that's a proposition that could be true or false depending on your perspective. So keep in mind the propositions don't necessarily have a very specific answer. So if I wanted to look at the opposite of that, I would just say I am not eating chicken. And that's going to reverse whatever my opinion was on that particular proposition. So if I thought I am eating chicken was true, then I am not eating chicken would become false. On the other hand, these nots, same as a sort of reversible based on the idea of your opinion of the proposition. So if I had thought that I wasn't eating chicken, the original statement I am eating chicken would be false in my mind. But I am not eating chicken would become true in this case because it would reverse what your thoughts on the proposition are. Sometimes you need more than not with spoken language. So if I have a particular phrase, I eat chicken, if I want to reverse this, it could become I do not eat chicken. This do that's inside of the statement is required for grammar purposes. The sentence wouldn't make sense without it. So there's definitely an interaction between language and these mathematical concepts. So eat chicken is true. I do not eat chicken would be false. And if I held the opposite proposition, I eat chicken would be false, and I do not eat chicken would become true. I'm going to skip section 1.4 a little bit here. In section 1.15, it talks about multiple negations. The standard phrase that everyone knows in English is pretty much I ain't saying ain't because ain't a word. Where ain't means am not. So there are a large number of nots in this sentence, all of them being am nots. And it's possible in general in most languages to construct double, triple, quadruple kind of negatives. So this is a quadruple. Well, it's not actually a quadruple. I think this is a triple because this one in here is just saying ain't, whereas these are am not. If I have the proposition I am not happy, then I could, in theory, reverse that by saying I am not happy. And when I say I am not happy, that in theory means I am happy. But if you've ever heard anyone talking who says I'm not happy, it doesn't necessarily mean the same thing. Multiple negatives sometimes don't really reverse everything depending on the context. Section 1.1.4, it talks about how groups can be weird when you apply negatives to them. So a group of students or a group of animals or something of that nature. So if I were to say, I am not hungry, that is a triple negative. And this works exactly the same as positives and negatives when you're doing algebra or order of operations type of math. So what I'm going to do is I'm going to count the number of odds, the number of knots, and if the knots are even, they will cancel out. If the knots are odd, it leaves you with a knot. So in this case, there are 3 knots. Those 3 knots would result in saying I am not hungry. If I move and have four nots, I am not hungry. Then just like with negative signs, there's an even number, so the knots cancel. And that just leaves me with I am hungry. This group of statements is my attempt at section 1.1.4. I don't like reusing the author's examples. There are some interesting samples in the textbook that I encourage you to have a look at that have results that are very unexpected when you do negation of all or none. So I'm going to do the straightforward versions, and I encourage you to look at the textbook for the not straightforward versions. So I could say all chocolate is tasty. And when I negate that, I'm going to put the not on typically the group name. So in this case, the not would be applied to all. So this would say not all chocolate is tasty. You may not write that way in English. Maybe it would be better to say some chocolate is tasty. Okay. There are also some examples that are similar to that concept of saying I am not happy, where things don't necessarily reverse with language, and that is especially true for groups. So have a look in the textbook for that example. In math and programming, there are other ways of using not, and so there's different ways, I guess, to visualize how you're talking about things. So the first one thing I could do is something that's called a function style, where I could use not as a function, just like you would in an algebra class or in programming. And I could say not and put in parentheses, I like chicken. That's equivalent to writing I do not like chicken. Now it can get a little bit more symbolic. In math, we in particular like to shrink things down. So for example, we use just symbols X or Y in a lot of cases when we're introducing algebra, and instead of using other symbols that may be longer or summarize things, like I could use the word chicken in math, but you'll frequently see as I'm introducing math at that level, I would frequently just call it chicken X, right? Well, I'd like to be able to replace other things like not with symbols. So the tilde character can be used to replace the word not. And if I use that with a function, if I wrote tilde and put in parentheses around I like chicken, then I would have I do not like chicken. Now, in addition to that, in math, we like to assign symbols to almost everything. So it's easier to write out on a piece of paper. We can do it quickly and clearly and know exactly what we're talking about. So I could identify a specific proposition using a symbol or a letter. And in this case, I'm going to create proposition A. You'll see A is in bold. I'm going to say A is I do not like TV. So if I were to write A anywhere on the paper below that, I would know that that means I do not like TV. I do not like TV. If I put tilde A anywhere farther down the paper, that would mean I do not like TV, or I like TV in this case. So this kind of allows me more power and flexibility to write things shorter. We're going to skip a lot of the sections that deal with this. These used to be covered more in the first edition of the textbook. They're not covered a lot here. So I'm mostly introducing a lot of these ideas to you so that you know they exist. There is still a little bit in this version of the book, but not to the extent there used to be. So as an example, if Dr. Seuss were to be a mathematician, I could define A as I like green eggs and ham. I could define B as I like them. And I could define C as Sam, I am not. So if I've done this, I can actually rewrite a lot of parts of the book just by substituting those symbols in the book. And it may not make sense to a child as a children's book, but I could reduce the amount of writing that I'm doing on a given page, and I could shrink Dr. Seuss down from, I don't know how long it is, 20 or 30 pages, down to just a single page potentially if I did this, because it's highly repetitive. So, for example, every page would end with not A, not B, not C. And if I substitute back in these values, that would be I do not like green eggs and ham, because I'm putting a not on the like. I do not like them. That's replacing the I like them. And then instead of saying Sam I am not, having the not C would make this Sam I am.